Today we will study the first theorem in maths, second part, basic proportionality theorem. Now statement of the theorem is, if a line is parallel to a side of a triangle, intersect remaining sides in two distinct points, then the line divides the sides in the same proportion. Now this statement has two parts. First part is, in a triangle ABC, let us consider a triangle ABC. In the triangle ABC, a line L is parallel to side BC, which intersect remaining two sides AB and AC in point P and Q. This is first part. Then the second part, this line divides the sides in same proportion. Means here first part is the given part, that is in triangle ABC, line L is parallel to side BC. This is the first part, given part. And second part is to prove this line divides the side in point P and Q. Second part is to prove that it divides in same proportion. Means here AP upon PB is equal to AQ upon QC. AP upon PB is equal to AQ upon QC. Now first we require the construction. So construction, join PC and BQ, join segment PC and BQ. Now last part of the theorem is proof. Now we will prove this theorem. So for proving this theorem, we will recall the properties of ratio of two triangles. Now observe this diagram. In this diagram, triangle APQ and triangle BPQ, APQ and triangle BPQ, both these triangles are having same height. Triangle APQ and triangle BPQ are having same height. Both the triangles have same height, so the property that ratio of area of two triangles, area triangle, therefore area triangle APQ upon area triangle BPQ is equal to, triangles with same height has the ratio, area of the ratio is proportional to the length of the corresponding bases. So base of this triangle is AP and this triangle is PB. So AP upon PB. Statement number 1. Triangles having same height. Triangles with same height. Now second part. Also, see triangle APQ and triangle CPQ. Same. These two triangles are having the different bases AQ and AC, QC, and has same height. So also in triangle, APQ and triangle CPQ has same height. Therefore, ratio of area of the two triangles, area triangle APQ upon area triangle CPQ is equal to length of their corresponding bases AQ upon QC. Statement number 7. Now, we will see that this PQ is parallel to BC and triangle BPC and triangle BQC. These two triangles are between these two parallel lines. Hence, the triangles which are between two parallel lines, they are having same height. Their heights are equal, and both this triangle PBC and QBC, both the triangles are having common base BC. So here triangles with same base and same height, equal height. Height is same as well as base is also same. So their areas are equal. So by property that triangle PBC and triangle QBC are having equal height since they are between two parallel lines and common base BC. Therefore, they are equal in area. The fourth property of ratio of area of what? Two triangles. So area triangle PBC is equal to area triangle QBC. Statement number 3. Now we will observe 1, 2 and 3. First, second, you will see the left hand side of both the equations that numerator is APQ, and if you see the denominator triangle BPQ and triangle CPQ, so here same triangle APQ and BPQ and QBC, they are same. So from 1, 2 and 3, from first, second and third, you get that left hand side is same. Left hand side is area triangle APQ upon area triangle BPQ is equal to area triangle APQ upon area triangle CPQ. Hence, the left hand side is equal from 1 to 3. Left hand side is equal, so right hand side is also equal. Therefore, AP upon PB is equal to AQ upon QC. Hence, the theorem is proved. Now, converse of the basic proportionality theorem tells us that opposite way of basic proportionality theorem. Here in triangle ABC if ratio is in proportion AP upon PB is equal to AQ upon QC, then line PQ is parallel to side PC. Converse of basic proportionality theorem. Basic proportionality theorem tells us that if line is parallel to side of the triangle, then ratio is in proportion. But converse tells us that if ratio is in proportion, then the line is parallel to the side. Now there are two applications of BPT, basic proportionality theorem. First application is angle bisector theorem. Now this angle bisector theorem tells us if in a triangle ray QS is the angle bisector of angle PQR, then PQ upon QR is equal to PS upon SR. It's a application of basic proportionality theorem, that is angle bisector theorem. PQ upon QR is equal to PS upon SR. And next, second application of BPT is property of three parallel lines. If line N is parallel to line M is parallel to line N, and these three parallel lines are intersected by two transversals line S and line T, then they divides these three parallel lines in same proportion. Means here AB upon BC is equal to PQ upon QR. These are two applications of basic proportionality theorem. Now using BPT applications and converse of BPT, will solve the practice set 1.2. Converse of angle bisector theorem. If in triangle ABC, AB upon BC is equal to AD upon DC, then ray BD is angle bisector of angle ABC. Now we'll start solving practice set 1.2. Question number 1, first example. In first example, we'll see a diagram is given. In triangle PQR, PQ is 7, PR is 3, QM is 3.5 and MR is 1.5. You have to identify the figure and you have to prove that ray PM is bisector of angle QPR. So here in this, the ratio in triangle PQR, in triangle PQR, PQ upon PR, PQ upon PR, the ratio is 7 upon 3. Second, QM upon MR is equal to 3.5, which is given, upon 1.5. Now this ratio, we can give the common multiple here too. Give the common multiple. If you give the common multiple for any ratio, the value doesn't change. So 3.5 into 2 is 7 and 1.5 into 2 is 3. Therefore, here PQ upon PR is 7 upon 3 as well as QM upon MR is also 7 upon 3. Therefore, PQ upon PR is equal to QM upon MR. Ratio in triangle PQR, the ratio is equal. Therefore, ray PM is bisector of angle QPR. If the ratio is equal, then it is a bisector. If ratio is not equal, then it is not a bisector. Question number first, second example. In second figure, we see in triangle PQR, in triangle PQR, PQ upon PR, PQ upon PR is equal to 10 upon 7. Then QM upon MR, QM upon MR is equal to 8, QM is 8 and MR is 6. Reduced to the lowest form, 4 upon 3. Here, both this ratio, if we give common multiple, it will not get an equivalent ratio. Therefore, here PQ upon PR is not equal to QM upon MR. Therefore, here ray PM is not bisector of angle QPR. Practice set 1.2, second example. In triangle PQR, PR is given 20, PM is 15, PQ is 25, NR is 8. You have to prove that whether line NM is parallel to side RQ. So for proving this, we should prove by converse of BPT. So first, we'll find PN and MQ. So PR is equal to PN plus NR, P dash N dash R. Therefore, PR is equal to 20, which is equal to PN, we have to find, plus NR is 8. Therefore, PN is equal to 20 minus 8. Therefore, PN is equal to 20 minus 8 is equal to 12. So, PN is equal to 12. In the same manner, we'll find MQ. So PQ is equal to PM plus MQ. P dash M dash between is Q. So PQ is equal to 25 is equal to PM 15 plus MQ. Therefore, MQ is equal to 25 minus 15. Therefore, MQ is equal to 10. Now, in triangle PQR, in triangle PQR, PN upon NR, ratio PN upon NR is equal to 12 upon 8, which is equal to, reduce to the lowest form, 4 1s are 4, 4 2s are 8, 4 3s are 12, 3 upon 2. And ratio PM upon MQ is equal to PM 15, MQ is 10, reduce 5 1s are 5, 5 2s are 10, 5 3s are 15. The ratio is 3 upon 2. Both the ratios are 3 upon 2, therefore PN upon NR is equal to PM upon MQ. Therefore, by converse of basic proportionality theorem, repeating, line NM is parallel to side RQ. Third example, in triangle MNP, ray NQ is angle bisector of angle MNP. Therefore, by angle bisector theorem, MN upon NP is equal to NQ upon QP. Here you have to find QP. You have to find. So MN, which is given 5 by angle bisector theorem, MN upon NP is equal to NQ upon QP. So MN is 5 upon NP is 7 is equal to NQ 2.5 upon QP, which we have to find. Now do the cross multiplication. 5 into QP is equal to 2.5 into 7. That is, QP is equal to 2.5 into 7 divided by 5. So 5 1s are 5, 5 0.5s are 2.5. So QP is equal to 0.5 into 7 is 3.5 units. Practice set 1.2, seventh example. In the seventh example, it is given the figure that AB is parallel to CD is parallel to EF. So three parallel lines and these two are the transversals. Find X and A. So by property of three parallel lines and their transversals, BD upon DF is equal to AC upon CE. So BD is equal to 8 upon DF 4 is equal to AC 12 upon CE is X. Now do the cross multiplication. Therefore, 8 into X is equal to 12 into 4. Therefore, x is equal to 12 into 4 divided by 8. 4 ones are 4 twos are 8, 2 ones are 2 6 are 12. Therefore, x is equal to 6 units. Now we have to find AC. Now AC is equal to between this. AC is equal to, we have to find A. A equal to, okay, see, A is equal to AC plus CE. A dash, C dash, E. Now A, we have to find AC 12 plus C is X. Therefore, A is equal to 12 plus X is equal to 6 unit. Therefore, A is equal to 12 plus 6, 18 units. Example number 8. In triangle ABC, ray BD is angle bisector of angle ABC. We have to find value of x. Hence it is angle bisector. So by angle bisector theorem, AB upon BC is equal to AD upon DC. Now we'll put the respective values of AB. AB is equal to x upon BC's x plus 5 is equal to AD x minus 2 and DC's x plus 2. Now do the cross multiplication. X multiplied by x into x plus 2 is equal to x minus 2 into x plus 5. X minus 2 into x plus 5. Now multiply these brackets. X into x, x square plus x into 2 is 2x is equal to, now multiply these two brackets, x plus a and x plus b. So x first term into second bracket, x plus 5 minus 2 into x plus 5. Therefore, x square plus 2x is equal to x into x, x square plus x into 5, 5x minus 2 into x, 2x minus 2 into 5, 2 5s are minus 10. Now on both sides of equality, x square same term, cancel it. Therefore 2x is equal to 5x minus 2x is 3x is equal 3x minus 10 as it is. Now take the variable on one side. So 3x will come here, 2x minus 3x plus 3x will jump, it will become minus 3x is equal to minus 10. Therefore 2x minus 3x is equal to minus x is equal to minus 10. Therefore x is equal to 10. Minus sign will get cancelled from both the sides of equality. X is equal to 10